Here we have it, inmotion S1 scooter. I've put a spintend ubox, 85 volt, 150 amp controller. Didn't quite fit, so I couldn't screw the front lid on. If I did it again, I'd use a 100 volt, 100 amp. I used a maker base before and that burnt out. It was totally crap. I blew up the BMS on the original battery. This scooter is the best for modifying. It's got a huge battery in it, 12Ah, 63 volt, fully charged. So yeah, to get like 50 k's an hour, you know, it's the best scooter, cheapest scooter to modify, and it's got a 1000 watt peak motor. So I've got a 20 amp BMS on it, but I've bypassed the discharge because obviously the currents I'm running are huge compared to 20 amps. So that's fine. The ubox will handle the voltage spikes and the current spikes, and it still balances the voltage across all the cells. So yeah, less resistance too, more power, more speed. So because I've bypassed the discharge, I can't cut off the power to the controller from the Bluetooth BMS. So I've got this little voltage key, so turn it off and it stops the battery power draining to the controller overnight. So that's handy for your battery lifespan. Obviously the LCD display is a different coding language. What the fuck? What happened there? Let's go back in the camera. Yeah. I've got a twist throttle. Got this battery light of Temu. I couldn't be bothered rewiring the lights at the front. So this just recharges or USB-C. It's way brighter than the factory, and it just wraps around the bar, so that's perfect. Yeah, so I've actually merged a couple of the wires between the throttle and the brake. So I've spliced the power line and the ground line going down to the ubox. So that means, yeah, the power wire, when it gets to the controller, you have to put it in the 3.3 volt. You'll burn out your controller if you put it in the 5 volt. So when you're doing your ADC setup in VESC, when you twist the throttle and pull the brake, you'll see that the minimum for the throttle and the brake is about 0.81 for throttle, 0.1 for brake. So you have to start from there as your minimum values, and then they both max out about 2.3, 2.5 volts. So that's your max in the ADC in the VESC. Current limits, based on the data sheet of these cells, they're really good cells. So they're like a 25R, but they're like some Triang. Anyway, I can send you the link to the data sheet of the cells. But basically, I can get a 37.5 volt amp continuous. So that's what I've said in VESC for battery current max. Motor current max is, I said that, 135, and absolute max current is 145. Alright, obviously, because that allows for spikes so you don't get cutouts. Before you do FOC detection, make sure you disable phase filters, and that will stop a lot of current cutouts. Alright, fuck's sake. Still recording here? Yeah. And yeah, another huge thing, tire pressure becomes super important at these high currents. So get yourself one of those battery powered inflators. I got mine off Temu for 17 bucks. and you don't need the valve extension. If you say you're going to use a foot pedal, so you can just hook that battery powered inflator straight onto the valves of the tyres, set it to like 52, and then when you detach quickly, you basically don't lose any air pressure and it comes back down to about 50. So yeah, huge thing to use when you're going at these high speeds and the current limits are tight. Yeah, but this is fine. I get about 50 k's an hour. Again, make sure you inflate your tyres, otherwise you'll get cutouts. Let's take it for a spin. Take it for a spin. Let's open the vest tool. You'll see that the motor doesn't overheat. I won't get any cutouts. So, regen braking. Set it to negative 12.5 amps and roughly about 27 negative motor current amps. So, the ERPMs. Make sure you set the reverse to negative 15,000 and max ERPM. So the throttle set it to 100,000. What was I going to say? Anyway, yeah. Let's take this for a spin. With you in 2 secs.